morning. Welcome to the week 2 of this course on architectural graphics or engineering graphics, and I'm your course instructor Dr. Avlokita Agrawal from Department of Architecture and Planning, IIT Roorkee. So in the week 1 of this course on architectural graphics, we understood the basic fundamentals of architectural graphics to start with. So what we saw was what are the different types of lines that we use in engineering graphics, what are the different type of graphic symbols that we use in architectural graphics and engineering graphics, and how do we do the lettering for the drawing. Besides that, we also understood about the different tools and the pencils, erasers, the different tools, how to take care of them, how to ready your board, how to put up your sheet. So all that basic things we have learned. One thing which is left as part of the basic understanding of drawing process is how to dimension the drawings, which is what we are going to pick up in today's lecture, which is lecture 1 of week 2. So today we are going to understand the rules for dimensioning, how to carry out the dimensions, and then we will see how do we really do it for these 2 sample drawings which I have put up here on this sheet. So our intent is not to start drawing today, but just to understand how the dimension would be done. So that is what we are going to be seeing. So for you, I have put up two drawings, one which has a lot of curves in it, so that we can make the curvilinear dimensions, we can dimension the curves, and the second one is more or less straight lines. So let us see. First, we should understand the rules of dimensioning, which is what I will demonstrate through this drawing here. Now, the first rule for dimensioning is that when we are going to read the drawing afterwards, we should be able to read it from the right bottom corner of the sheet. So, the dimension ideally should be either on the left hand side of the sheet of this drawing, or it should be in the bottom of the drawing. So either the dimensions would come here or here. However, sometimes when the dimensions cannot be represented here, they can be represented on the right side and top as well. But our intent, our initial aim should be to place the dimensions on the left hand side and on the bottom of the sheet. That is what we would try. That's the first rule. The second rule, which is most important, is that no two dimension lines should cross over each other. They should not intersect. Now, what would that mean? How does it manifest when we dimension? We will see in this drawing. But no two dimension lines should intersect, because it will become very confusing that which dimension line is, or which dimension is representing which side or which dimension of the drawing. So the intersection is absolutely prohibited while dimensioning a drawing. Another rule which is very important is that we often, it is very rare, but often we do not dimension inside the drawing. It is very rare, either when the drawing is too large, that we can clearly read the dimension inside without interfering with the construction lines, all the lines that are depicting the drawing. So in that case, we might put the dimensions inside the object, but in all other cases, we would try to have our dimensions outside of the object. So I will start drawing the dimensions, and then we will see, and then how do we really dimension, what is the thickness of the line that we take, and all those things. Okay. So we start dimensioning this drawing. Now here in this particular drawing, let us first draw the extension lines to understand that what all do we need to dimension. So what we need to dimension? We need to dimension this bigger dimension, the full dimension. Let us take only the vertical dimensions initially. So let me draw in very thin line. So I am using a 2H pencil here, and I am just drawing the extension lines initially. So these extension lines will always be drawn in very thin lines. and these thin lines should be drawn almost faint enough not to be seen. So if we are making these lines using a 2H pencil, they would hardly be seen afterwards. So if we look at all the vertical dimensions which will be shown on the left hand side of the drawing, we can see that there are too many dimensions which are coming together, especially these smaller ones. So a smaller dimension is in the front while a slightly bigger dimension is coming from the back, and then the bigger dimensions are to the front. So the ideal way would be that we take out these curvilinear dimensions and put them to the right of the drawing. So that is what we are going to do, and on the left hand side we would rather dimension the remaining ones. So let me draw few of these dimension lines, and then we will see that what is the dimension which is going to be shown here. So always, as a rule, the smaller dimension will be closest to the drawing. So if we look at this, we can see that the smallest dimension in this particular part of the drawing is that of the circle, this semicircle. So, and then the next one is this dimension, these two flat ends, and then we have an overall dimension which is this. So what we can see here is the next one. We can go on to use the HB pencil. So the first thing, the first line which we have here, and kindly remember that for the dimension line we have to use a very thin sharp pencil. Now when we draw this dimension line, the extension lines are anyways coming in very thin faint lines, and then these are the markers which will be drawn to the end of, to mark the end of the dimension line. So these are small lines which are marking the ends of this. At an angle to these lines, say an angle of 45 degree, we will mark another line. This is the dimension line. Now, whatever the dimension of this semicircle is, so let us measure, and suppose it is approximately 6.7 centimeters, and if we are dimensioning this drawing in it depends upon what is the unit that you are following, but whatever unit be, it will be followed uniformly depending upon the scale. So suppose this drawing is being drawn to a 1:1 scale, so in actual size, and this is 67 mm, all the dimensions are in mm here. So on top of this, since we are going to be reading it from this side, we will be writing the dimensions on top of the dimension line. So we will be writing 67 mm, and mm units will not be mentioned. "67". So if you look at this, the dimension is going to be read from this side. This is the shortest dimension, 67 mm. The unit will be mentioned separately. The next, we could either take the flat ends, the next set of dimensions, to the other side, but then there will be no dimension in the center. So what we would do is, we would only continue extending the same line. So we could have continued extending the same line initially only, or we could do it later, but it is just an extension, a continuation for the same, and we mark further the ends. So we mark the vertical markers, we mark the horizontal markers, and then we write the dimension on top of it. So, approximately let us see that, say this is 20 mm each. So, we write on top of these lines. So, the dimension which is mentioned here is for this part of the dimension line. The dimension mentioned here is for this part of the dimension line is what it is implying. This is one way of dimensioning. We will also see the other way of dimensioning, but for now this is what it is. So, we have already dimensioned this part and we have dimensioned the two flat parts here, and then we will take the bigger dimension, which is the complete dimension. Similar to how we did it, we will mark the bigger dimension away from the drawing. So, it will always be the last dimension to be read. If we are marking to the left of it, this will be the biggest, and say it is 120 mm. So, we write it like this. So, the horizontal dimensions of this side have almost been covered on the left hand side. Now, we will mark the extension lines for the horizontal dimensions, and let us see how do we mark them here. So, let us start drawing to the bottom of the drawing. We will also be needing to mark the center for the curves. So, it is not just the object, but also from where the centers will be taken. So, I am marking the extension lines which will determine how the dimensions will be given. These are all very thin, faint lines, as I repeatedly say, and we have to be very careful that initially only the light lines are being drawn. So, to start with, we may be dimensioning this part which is in the center. We might be requiring to dimension this part. We might be requiring to dimension what is the overall dimension of this object from end to end. We might be needing to know where is the center for these two curves, which is circular, coming. So, from the end, what is the dimension for this, and then this, what is the distance between these two curves, or what is the distance between these two centers. So, this is what we will mention here. So, I start by mentioning the dimension for the straight parts first. So, we have these dimensions which we will be mentioning now here, and when we are marking the dimensions in the bottom of the sheet, the dimension will be read above it. So, what I intend by this is, and by the way, the end markers will all remain parallel throughout. So, if we have taken it in one particular orientation, throughout the drawing, entire drawing, the markers will come in the same orientation. They cannot change. So now what we have is how much is the distance from this end of the object to the center of this curve, say 35 mm, we write it on the top of this dimension. Since it will be read from this corner, so either we write towards this side or towards the top. So we know that the center of this object is at 35 mm from the end, which is easier to mark. Now, the two centers, so this is at say 75 mm, this rectangular part is 75 mm, which is what we have written here. We will also write what is the distance between these two curves, or we could also write what is the distance between these two centers. So we may write another dimension here, which is the distance between these two centers. So the intent is to actually mention the dimension which is required to draw or construct an object. So maybe this is required. If you feel that another dimension is required to actually draw, that is what will be drawn. If we see, this is another say 20 mm. Which is what we have mentioned here. The flat surface of it, say 25 here. This is say 13, so I mention it 13 here. Now, what is required to draw this is the radius for all these curves. So how do we draw the radius of these curves? What we do for curves is we will mark a leader. So as I told, the leader is almost as dark as the dimension line itself. And what we do at the end of the leader is that we draw this horizontal line, which is like the dimension line. So what we do here is we make an arrowhead like this. So the thickness of the arrow is 1/3 its length approximately. So this is the curve, and we mention that this curve, whatever radius it has, so this curve has a radius of say 13 mm. So we write circle with radius 13. That's how we mention this curve, and similarly we will mention the other curves. The arrows have to be symmetrical. They should not be like more on one side and less on other side. We have to be careful about that. So say this is 20. So a circle with radius 20 mm. It is all in mm. And all the arrows should be same sized. So this is with a radius at a radius of say 13.5. So a circle with a radius of 13.5 mm. So that's what we are writing. So this is actually 35 mm. So at a radius of 35 mm. So this is how we have marked where the center of the circle is coming. So we know where the center of this circle is coming. So we can mark this circle and another one. Then we know that from this center, the next center is coming at 57, and if you realize, you can very clearly see the center line being marked. So there is a big dash and a small dash like that. So along the center line, we now know that the first center is at 35 mm and the next center is at 57 mm, and the next center is at 75 mm from that, and the radius of this is 13. We can again mark the radius for this circle as well, semicircle. We already know this, or we could also mark the radius for that. We also need to know the radius for these two curves. So, we will again draw another one with the radius mentioned. So, for example, if the radius is say 27, so the radius for this curve is 27, and we would mention another radius for the curve there, and that is how we would have mentioned all the dimensions here. In case some dimension, okay, so one more dimension which is left is the overall dimension of this particular drawing, which is always necessary. So, we should always mention the overall dimension of any drawing, the final dimension, outer dimensions, and in all cases the total dimension should match up to the sum of these smaller dimensions. So, say 220. Here we have not mentioned this dimension, and this dimension, so it does not matter, but in case we were doing that, all these dimensions should have added up to 220. For now, it does not matter, we can reduce the dimensions in between. So, this is R27, so we know that this is 27, we would know that okay, this is R13, so this is 13, and we know this is R20, so this is 20. So, overall all these dimensions should add up to this one. That is what our aim is. So, this is how we would dimension the curves and a drawing which has a lot of curves and straight lines. Another way of dimensioning, which I am going to show on this drawing, is if instead of these marker heads, the inclined marker heads, we use the arrows. So, to start with, we will again start with drawing the extension lines. So, okay, another thing, when we are drawing the plan elevation and the side elevation of it. So, what we are, sorry, this is the plan, this is the front elevation, and this is the side elevation of it. So, when we are dimensioning, we would be dimensioning separately for plan, separately for elevation, and separately for the side elevation. However, when the drawing is going to be read, a dimension which is already mentioned in plan may not necessarily be repeated again in the elevation or the side elevation. So, we may omit certain dimensions. Okay. So, let us quickly draw the extension lines. So, we would first quickly draw the horizontal and vertical both extension lines, which is what I have done to start with this drawing. So, if you can read this drawing, it is basically a shape where what we have is, we have a sheet-like of structure. We have a sheet-like of structure, a vertical sheet, which is in the side elevation seen like this. In front of it, we have another structure like this, which is like a U, and it has some thickness, and it is depressed from the center. That is why you see this hidden line. So when you see it from the side, there is one entire rectangular face, which is this, but then at the back of it, we know that it is being cut. So that's what the drawing is. Now, what you need to know? You need to know the radius of this. So here we can mention the radius of this circle, which will be mentioned here. Then we need to know the center of this circle from the top. So this is the elevation drawing. We can see the dimensions in elevation. We would need to know how much, at what distance from top is this circle, the center of the circle, which is what we will mention here. Then we would know what is the depth of this one from the bottom. So we know this on the same line. Then we have the remaining depth of the bottom part, which is here. And then we would know that at what height is this center. So that's what I have drawn here. And again, just like we have done for the previous drawing style, the dimensioning style, we would draw the horizontal markers, which will always be there. Whether we use arrows or not, doesn't matter. We will have to use the horizontal markers. But then instead of these diagonal markers, sometimes we can actually use the arrows. So when we are printing, it is easier to use arrows. When we are drawing with hand, sometimes it becomes smudgy because the arrows are usually filled up. They are filled, and we need to be very particular that all the arrows have to be the same length and width. Then the drawing looks good. If you can't make those arrowheads, you better stick to these inclined marker heads. So we would dimension how much, at what distance from the top is the center being placed vertically, and then from bottom, what is this distance? So I keep writing down that. So say 18, say another 18, and from top it is say 28, whatever is coming. So that's what we've mentioned. We've mentioned the thickness of this one, the height of this one, and the center from the top. And we can then also write the overall height of this object. So we have the overall height of the object, and the dimension style will remain the same arrows, and they don't increase or decrease in size. So this one is approximately 9.2, so 92. That's what in elevation we get. I don't think we need anything more than that. Here we need to know the radius of this. So if you know the location of the center, all we need to do is know the radius of it. So say the radius of it is 18. So we know that the circle with center here has a radius of 18, and we should be able to draw that. Now, what else do we need to know about it? In elevation, we may be interested to know about, say, two dimensions. One, the inner dimension, the outer dimensions of the sheet on top, and the outer dimension of the bottom part. So we will again mark these. So this is the dimension for the top part, which is coming down like this. So the extension lines have to be very clear. They have to communicate where this dimension is coming from. So we will mention the dimension. So say 91, and then the outer dimensions, say 110, like this. So this is how we are reading this. Now, one more thing which is still left is where is the horizontally, where is the center placed. So that is what we can get in this drawing as well. So in the plan, maybe we can get to know that, okay, so maybe that the center is placed at the midpoint of this line. So we draw another extension line, and what we can also write, so we already know that this is 91. So we can also write equal. So sometimes we may not be able to divide or give the dimension for it. We could just write EQ, which means that both these dimensions are equal to each other. This is what we write, and we can just bisect this particular drawing and say this is equal. These two parts are equal. So this part is equal to this part. We don't need to give the dimension sometimes, or you could also give the dimension if you feel it is necessary. And then in the top one also we would give the final dimension. So this is what we will write, and always the outer dimensions of the drawing should always be the same. So if it is 110, if it is 110 here, it has to be 110 here. The outer dimensions must remain the same. So now this particular dimension will not be seen anywhere. So we need to mention, and preferably try to maintain the same dimension. So this is what it is seen from the top. Okay. So we will mark this dimension, whatever this dimension is, use the same dimension style. So this is what is seen from the top. So for this one, this dimension is also seen here. So it is, say, approximately 18 again. 18 is the thickness of this one, and for the other plate it is 36. So for this one it's 36. So we know the thickness. Now this 36 is equal to this 18 is equal to this, and this height is equal to this width is equal to this. So that's what we have, more or less. We have already given the dimensions. We may or may not dimension this one, but at least we will dimension the outer ones. Now since there is not enough space between these two, we would prefer to dimension it towards the right, unlike in the previous drawing. So that's what we will do. Now without even looking at or measuring it, I should know that this is 92. But which side of the dimension would the dimension unit, the number will be written? It will be written away from the drawing. That's the rule. So when we mark the dimension, it is always towards the outside of the drawing. We never write it in between the drawing and the dimension line. So that's what we are doing here. Again, we will draw the extension lines, and we'll make the arrows and all, and without even seeing, I can write that this is 36 and this is 18, the same dimension as is coming from this. So I hope with this you are reasonably clear about how to dimension a drawing. Making drawing is important, but dimensioning it is equally important. We have to know how to dimension this entire drawing, otherwise the drawing will be of no use. So that is the end of my lecture 1 for week 2 today, and we will be starting with the fundamentals of basic geometrical construction in the week 2 lecture 2. So see you again for the next lecture. Thank you.